In this video, we're going to look at geometric series. In the previous video on arithmetic series, we saw that a series is the sum of the terms in a sequence. So a geometric series is the sum of the terms in a geometric sequence. And if this is our sequence, 1, 3, 9, 27, etc., and it's geometric because to get each successive number we're multiplying by 3, then the corresponding series would be 1 plus 3 plus 9 plus 27, etc. And I'm going to give you the formula for the sum of a geometric series, then we'll do some problems with it, and then in the next video I'll show you how it's derived. So the sum of the first n terms of a geometric series, s sub n, is equal to a times r to the n minus 1 over r minus 1. And you need to be a little bit careful here because you're used to writing the general term for an arithmetic series or an arithmetic sequence, which is a times r to the n minus 1. And here the minus 1 is up in the exponent with the n. But here the minus 1 is not. So you have to be just a little bit careful that you don't get that mixed up. Let's do some problems first, and then I'll show you where that formula comes from. So a raffle offers 30 prizes. The first prize is $25, and each succeeding prize is twice the previous prize. So the first prize would be $25, the second prize would be $50, the third prize would be $100, etc. And we're asked to find the total prize money, so we want to add those all up. And we don't know what the last prize value is. We could work it out though. So we're given that A is equal to 25. The first term in the series is 25. We're given that the common ratio is 2 because the prize value doubles as you get to each one. This is times 2, this is times 2. And we're given that there are 30 total prizes, and we're asked to find the sum of the first 30 terms in that series. So the sum of the first n terms in a series is equal to a times r to the n minus 1 over r minus 1. That's the formula I just gave you. And if we plug in 30 for n and 25 for a and 2 for r, we get 2 to the 30 minus 1 over 2 minus 1. So that's just 25 divided by 1. So we get 25 times 2 to the 30 minus 1. And you're going to need a calculator to work that out because it's a very big number. It's 26,843,545,575. So you can see that in in a geometric series, the numbers get very big very quickly. That's a lot of prize money. Here's another example. Find the sum of this geometric series. Now, there are a couple of ways of doing this. Let's look at one. We know that the first term, a, is equal to 8. We can work out quickly that the common ratio is 2. We don't know how many terms there are in the series, so n we don't know. And we know that the nth term is 4,096. We don't know what place that is in the series, and we're asked to find the sum of that series. One way of doing this is to first find out what number term this is. So to do that, remember that the nth term is equal to a times r to the n minus 1. We use the same formula for geometric series as we do for geometric sequences. Plugging in, we get 4,096 is equal to 8 times the common ratio 2 to the power of n minus 1. We want to work our way into this n, so we're going to divide both sides by 8. 4,096 divided by 8 gives me 512, so 512 is equal to 2 to the power of n minus 1. Now, if you are familiar with logarithms, you can use logarithms at this point, but otherwise you want to just use guess and check and work your way up to figure out what power of 2 this is. And it turns out that 512 is 2 to the power of 9. So 2 to the power of 9 is equal to 2 to the power of n minus 1. If the bases are equal and the left side is equal to the right side, then the exponents must be equal. So 9 is equal to n minus 1. Moving the 1 over, we get that n is equal to 10. This is term 10. Now we know what we're looking for is the sum of the first 10 terms. The sum of the first 10 terms is going to follow this formula. So we just plug in all the values that we have. A is equal to 8, r is equal to 2. Now we know that n is equal to 10 minus 1 over 2 minus 1. This is 8 divided by 1, so that's 8 times 2 to the power of 10 minus 1, which is equal to, using a calculator, 8,184. There are other ways of doing it as well, but that's one way of approaching that problem. So that's an introduction to geometric series.